this video, we will continue with revision exercise 7 of integration. You will find this on page 360 in the Namibian AS-Level Mathematics textbook, y equals mx plus c to success. In the previous video, we were looking at 1 and 2. So in this video, we are going to focus on number 3 as well as number 4. Okay, I will just move it up a little bit, then you can stop the video. Then you can first do number 3 and 4, and as soon as you are finished, you can continue the video. Okay, let's start. Number 3. The diagram shows part of the curve. There is the curve. Define and x is bigger than 0. It's just on this side. Okay, equal to 0. Find, showing all necessary work, the area of the shaded region. Now let's start with what is the curve. It's y equals a half, and that's x to the power of 4 minus 1. Okay, just take note, let's rather write it there, sorry, that I can also write it like that. Okay, now show all the necessary working, the area of the shaded region. So if I want to find the area, I am going to make it definite integer. It's between 1 and 0. And I'm going to work with that formula. So y x4 minus a half. And it's going to be dx. Okay. So now I'm going to start and I'm going to integrate. So this is going to be a half times. Now remember, this is 4 plus 1. So it's x5 over 5, and there is the constant, and then it's just x, and it's 1 and 0. Okay, so this is going to be x5 over 10. Okay, so I'm just going to say it's not necessary to do this step, really you could have just started substituting. Okay, but let's start. So I'm first going to put 5 divide 10 minus a half 1 minus, okay, bracket 0 to the power 5 over 10 minus a half 0, close the bracket. And then it's 1 over 10 minus a half, and that will just be 0. Okay, and that, just let's see, where is my problem? There's a problem with this one. So, okay. So it's 1 over 10 minus a half. So let's just press on your calculator. I don't think there's a problem. So 1 ABC 10 minus 1 ABC 2, and that's negative 2 over 5. Now you say, but there is a problem. Area cannot be negative. It's just negative because it's underneath the x-axis. So you're going to end up say, therefore, area, so positive 2 over 5 units square. Okay, so that's the first one. Number B, let's move on. That was number A. Number B. Find, showing all necessary working, the volume obtained when the shaded region is rotated through 360 about the x-axis. Okay, remember volume is coming from area of a circle. It's area, so it's pi r squared. So volume, and you can go back to the chapter, equals pi and the formula squared. Can you remember? So I'm just going to take, still 1 and 0, and I'm going to take that formula, that one, okay, so x4 over 2 minus a half, and I'm going to square it because it's coming from the area of a circle pi r squared, okay, and I'm going to integrate to x. So it's just a little bit more simplifying now, and the pi's just moving along. Okay, so let's just first get this. Now, I like to do it rather on this side, so it's x4 over 2 minus a half, and that x4 is not looking nice. x4, let's just move it a little bit, over 2 minus a half, but I know it's x4. Okay, So if I multiply, I get x, I add the exponents, 8, 2 times 2 is 4. If I multiply, I get x 4 over 4. I get x 4 over 4. And now the last one is negative 1 over 4. So if I'm going to rewrite, and remember I did not integrate yet, I'm just running along with the formula, getting that square away. So I'm going to have x 8 over 4. Okay, can I just, this is minus 2 over 4, so it's minus a half over x4. And this, a negative and a negative, I almost made a mistake there. It's plus a quarter. And it's going to be integrating 2x. Okay, so now I'm going to integrate. So remember, this is plus 1, so it's x9 over 4, and there is the 9 minus a half. Then it's x5, and multiply, and there's the 5. And then this one is just getting an x. And it's 1 and 0. And then it's pi, and it's going to be x to the power of 9 over 36 minus x to the power of 5 over 10 plus x over 4, if I want to put all the x's on top. Okay, now I substitute. Now if I'd leave this, but then I just put a bracket. So I substitute 1, so it's 1 to the power 9 over 36 minus 1 over 5 over 10 plus 1 over 4 minus, and now I put 0. So 0 to the power 9 over 36 minus 0 to the power 5 over 10 plus 0 over 4, and I just simplify. Okay, and now I just run along this pi. So I'm going to get 1 over 36. This is going to be 1 over 10 plus that quarter. And unfortunately, all this 0, 0, 0 will just, but don't always think is 0, especially if it's e, but that's more in further integration. Okay, and now I can just basically take my calculator. I can just press 1 ABC 36 minus 1 ABC 10 plus, but at the end I will get 8 over 45. So therefore, volume is 8 over 45 pi, and it's units to the power of 3. Okay, that was number B. Let's go to number C. Okay, now again, I'm going to, just for my space sake, I'm going to do number C here. Just going to make it like that. And then, because then I can compare it there. Okay, so let's start with number C. Find, showing all necessary work, the volume obtained when the shaded region is rotated 360 about the y-axis. Okay, so it's still going to be volume. It's still rotation, but it's now not around the x-axis, it's around the y-axis. Okay, so we're going to still say volume. Now before we start there, just take the formula. Now, always remember, if you take this formula, it's going to be y is equal to x to the power 4 over 2 minus. You must make now x the subject of the formula. Okay, now let's do this. Now, if I'm going to get that this is going to be 2y. Oh, let's just keep to blue. Now, what is going on? Come blue. 2y is equal to x to the power 4 minus 1. Okay, so basically 2y plus 1 is equal to x to the power of 4. Now, just for the interesting, and I'm going to do it like this. Because volume, you must square the formula. But if this is already x squared, then you don't have to square it. Now, how do you make it x squared? Okay, if I go and I multiply this, now I want to take red. I multiply this with a half. Okay, but then I must also multiply this with a half, because then it's already squared. Otherwise, you can go to 1 and square it again, and you're going to basically get the same then. Okay, so this is just going to be 2y plus 1, and that's going to be 2½ So if I go now to volume, which I want to get, so volume around the y-axis, it's still pi, and now it's the formula squared, but it's already squared. Do you see? So it's that 2y plus 1, and it's just going to be 2 that half, and it's now integrating to y. So if I'm doing that, no, I don't want to take, I just want to continue. I get pi. Okay, I'm going to integrate. Now, remember, it's that 1 over, so it's going to be 1 over 2, that's the value of a. Then, okay, I like to make that bracket smaller. Then it's 2y plus 1. Now, remember, if you have a half plus 1, so plus 2 over 2, then you're going to get 3 over 2, okay? Then it's 3 over 2, and you divide by 3 over 2, okay? And then you are going to still, oh, I forgot, and I have to show you. Forgot it, but I have to show you. Just go back. Go to the sketch. Do you see? It's negative a half and 0. So 0, negative a half. So the further one is going to be 0, and I forgot to put it in. So this is 0 and negative a half. Okay. Now I'm just going to simplify before I want to do the calculation. So remember, this was now, I want to take another color again. This was a half multiply, if I reciprocal 2 over 3. So this is, so it's 1 over 3. Do you have that? So it's 1 over 3. So it's actually that 2y plus 1. Are you with me? And that's 3 over 2. And over that 1 over 3. Okay. And then it's 0 and negative a half. Okay. Let's just go up. And now I'm going to substitute. So I first put my 0. So 2, 0, plus 1 to the bracket. 3 over 2, divide 3. Okay, fine. The next one, so it's 2, and then negative a half, plus 1 to the power 3 over 2, and then over 3. Just that in the place of y. Okay, let's do that. So I'm getting pi. Okay, now this is 0, but there's 1. And 1 to the power of, it's 3 over 2 is just 1, so it's just going to be a third. Now the problem here, what happens? It's negative 1 plus 1, so it's 0, 0. So that is all going to become. And what is my answer? 1 over 3 pi. And that will be units squared. And that's how I do that. It's a very nice question. It's testing so many things. Okay. Okay, and then we are at the last one, and that will be number 4. And we have to make a lot of space, lot of space, lot of space. Okay. It's not so long. Just getting all this question 3 was long. Just getting it out of the way, out of the way. So that I can start with 4. Okay. Okay, it's almost done, almost done. Oh, and it's still cleaning. Okay, it was really a very, very long question. Okay, this is the finals. Okay, let's just move it up. Okay, there is number 4. All these lines, it's just with the moving coming usually in. Number 4 is not so long, so I'm just going to, there it is, nice now, standing nice. Number 4. A particle travels in a straight line, passes a fixed point O. Its velocity, remember, centimeters per dis, t seconds after passing O is given by this velocity. Now, you have to think of, and it helps if you have physical science, you have distance, and then you have velocity, and then acceleration. Remember, we you must have this picture in your mind. We differentiate, and when we come back, we integrate, and we integrate, and that's going to help you. Okay, but let's start. In this case, they give you the velocity, so they give you the middle one, which is a nice one, because then you can go differentiate and you can actually integrate. Okay. Okay, and then they start with number A. They say the particle travels straight, passes through the point, okay, given by this. Find the maximum value of V. Now, remember, if you're going to see it in terms of a graph, and I want to show you in terms of a graph, it's going to do a curve. It's going to do this, okay. So if I'm first going to do, and I'm going to get this, but at the end, I want this value. Okay, did you see that? So I'm first going to differentiate. Okay, that's correct. So I'm going to take this formula, it's actually to get acceleration, and I'm going to say dv over dt to get that acceleration. It's actually to get that value there. Okay, and then I can substitute it in the original to get that value there. But let's first, okay, if I differentiate, I get 26 minus 6t. Okay, are you with me? Now, at that maximum, I'm looking for that value. So, at maximum point, sorry, pen, come. Point, dv over dt is equal to 0. So it's going to be 0 equals 26 minus 6t. So 6t equals 26. So divide 6. So therefore, I found that t is 4 1/3. So there is my t. Okay, so that is 4 1/3. That's what I got. But I want v. I actually worked with I differentiate to find that derivative function so that I can find that 4 1/3. But now I actually want v. So I put this in the original equation. It's just like finding that turning point. That's basically what I'm trying to do. I have the x value now in bracket, and I want to find now the y value. So take this and put it in the original. Okay, and if I'm putting it in that original, you can just go and simplify because I'm looking for that value. So it's 10 plus 112 2/3 minus 56 1/3, and that's going to be equal to 66 1/3. And remember, velocity was in centimeters per second. Okay. So this was 4 1/3, and this was that 66 1/3. But to get that turning point, I had to take the equation. Actually, let's make it red. I had to take the equation. I have to differentiate it. I have to put, make on the turning point, it's 0, and then I found. So it's just like finding stationary points. Okay. And then the last one, number B. The distance of the particle from from 0 to t. Distance. Now, as soon as I see distance, I have to think of what I showed you here. I had velocity. To find distance, I have to integrate. Do you see that? And it's between, I'm actually telling you it's between 2 and 0. So to find that is, I'm going to integrate that between 2 and 0. And that's going to be 10 plus 26t minus 3t squared dt. And that is going to give me, okay, 10 integrate t plus 26t2 over 2 minus 3t free over 3, and don't forget it's 20. Okay, so if I simplify, I just want to make it a little bit, plus 13, I'm just going to 13t squared, and that's just minus t to the power of 3. And now I just substitute. So this is going to be 10, 2, plus 13, 2 squared, minus 2 to the power of 3, minus bracket, and now I simplify. So this is 10, 0, plus 13, 0. Don't always just think it's 0, especially in further integration. Okay, maybe here. Okay, so this is going to give me then the 20 plus the 52 minus the 8 minus that 0, and that's going to give me 64 centimeters. And note it's the same as the area under the velocity time curve. So it's the same as the area, say if that was under the time and the velocity curve. The area is always going to be this integration. And that's how you do it.